Hello, it's Mr. Claudia here, and today we are going to be learning about cumulative frequency. As with all the lessons in this part of the statistics chapter, cumulative frequency graphs and tables are a way of presenting data so that it's easier for someone to look at and analyze. This is something that's new to us. We haven't ever seen a cumulative frequency graph before, but we're going to see that it's not too difficult to draw and it's pretty easy to use once we've made it. Basically, cumulative frequency is all about the cumulative amount of statistics. So it's a progressive total as you go through your values. Think of like a cumulative review is a review of everything you've done. We're going to be looking at cumulative frequency table and making cumulative frequency graph, which is also called an ogive. I guess that's a fact if you ever need it for Jeopardy. Ogive, that's how it's pronounced. For a cumulative frequency graph, we can read lots of information that we can't from just a regular table. We can read the median and the quartiles. So let's just do one giant example. This will really help clear up how it all works. So we have some data from the women's marathon at the 2008 Olympics for all competitors who finished the race. So here it is here. So the women who finished between 146 and 148 minutes who won the race. So there were 8 in that first that range. Then 3 in the next 2 minutes, 9, 11. You can see a lot of competitors coming in here. And then we have the last, in between 168 and 176, we had 6 competitors come in. So we're going to construct a cumulative frequency distribution table. So now for that, we're going to make a separate column in my table, which is cumulative frequency. And now we're going to look at each bin and take a progressive total. For example, when I get to 148 minutes, how many competitors have crossed the finish line? 8. When I reach 150 minutes, the end of the second bin, how many competitors have crossed the finish line? Well, 8 already plus 3 more. So my cumulative total is 11. After the next 2 minutes, I have another 9 competitors, so now I have a cumulative frequency of 20. I think you can see how this is going. We keep adding the next value to my cumulative total. And then we end up, by the end of 176 minutes, we have 69 competitors who have finished the race. So let's just make a quick note here. How did I calculate this value, 11? Well, that was 8 plus 3 equals 11 competitors. Finished in less than 150 minutes. Okay, so now we want to, after we have the cumulative frequency distribution table, we need to represent this data on a cumulative frequency graph. So join me in making this graph. Now, the thing that we're representing, remember, there's only one statistic here. There's a frequency, but there's only one statistic, and it is the finishing time for women in this marathon. So that is just like when I made bar graphs, the one statistic I'm looking at goes along the x-axis here, the bottom axis. So that's my finishing time in minutes. Now, we are going to have a little break in the graph because I'm not going to show, the time that's less than 148. But then I'll have 148 here. I think I need to go up by 2s. So 150, this is 152, 156, 160, 164, 168, and 172. So that's my finishing time. Okay, and on the y-axis then is the frequency, the number of times each thing occurs. For this case, because we go up to 70, that's going to be my max. So I'll draw my So on this axis, I'll draw my cumulative frequency. I think I have to go up by 10, well, technically by 5s. Oh, perfect fit. So I'm just going to label that cumulative frequency. Okay, now let's start graphing. So our first point was 48. So, here's the question. What do I use when I'm graphing, that there are 8 finishers between 146 and 148? I could use the lower bound, 146. I could use the upper bound, 148. I could even use the average, the central value, which I did previously when I was measuring central value. You usually do use the central value when you're dealing with grouped frequency data like this, but when we're dealing with cumulative frequency, we're always looking at the cumulative number up to the upper bound. Like this is telling us that the 8 people finished before 148, 11 before 150. So when I graph this data, I'm always going to graph for cumulative frequency using the upper bound. This is something that some of you will forget on the quiz. So I'm going to put a note here. Always graph cumulative frequency using the upper value. Like I said, almost every other time you use the middle value of the range, but not for cumulative frequency. In that case, you use the upper value. So my first point is 148 when I had 8 women finish. Now the next point was 150. I had 11 women finish. Then we have 152, we had 20. 154, we had 31. 156, we had 43. 158, we had 50. 160, we had 55. And be careful here, it jumps a little bit at the end. We go up to 168, which is way over here. That is at 63. And 176, which is 69. Oh, so it's a little bit off the page here. Now that I've graphed all my points, I can connect them in a smooth curve, and which is the drawing the ogive. Remember that term for Jeopardy. That's the shape this makes. There we go. So that is the cumulative frequency. Before we do anything, looking at the shape of this cumulative frequency, you can kind of see, you could compare this to another race, but you can see that at first, as the time was small, we had a few people finish the race. Then around 155, 154, 155, we see the curve goes up very quickly because a lot of people are finishing the race. And then it eases off. So in the last, 12 minutes, it really slows down and very few people are entering the race. I saw a lot of cumulative frequency graphs during the early days of the coronavirus, because we would track the number of cases. Now it was a log scale, so that's something else, but we tracked the number of cases cumulatively in different countries. So we'd see the curve for China, which went really, really, really steep and then started to level out. And then we saw Italy, and it went even steeper, and then it started to level out, but way higher because more people got it. And then we had Canada, which started off steep, but then we had all these measures, so we kind of started to level out a lot earlier. So anyways, cumulative frequency graph, that's what it looks like. Now the great thing about it is we can use it to make a lot of estimates. So let's start with question C. Find the median, or estimate the median finishing time. So let's see if we can fit all this into this page. You should be able to. Okay, median. Now remember, median is the 60, n plus 1 divided by 2, which would be the 70 divided by 2, 35th value. Well, it just so happens the cumulative frequency graph can be used to tell me this. So the 35th value, well, look, these tells me all that. Remember, I have 69 values in total, 69 runners. So the 35th is right here. So I'm going to draw a line from 35, and then where it intersects with the ogive, with the cumulative frequency graph, I'm going to draw a line down to the x-axis. So that is the median. And you can see then you can make an estimate now from the graph. The median is, okay, what do you think? Well, this is 154, this is 156. Let's say 155. You can see that this is an estimate. The cumulative frequency graph, if you draw it slightly different, or you draw the line slightly off, it's going to be a slightly different number. So we understand that this is only an estimate. Part 2, find the interquartile range of the finishing time. Well, remember, interquartile range is the Q1 minus Q3. So in much the same way I found the median, I have to find Q1 and Q3. Q1, if you remember the formula from yesterday, is 1/4 of n plus 1, of 69 plus 1. So that gives me 70 divided by 4, which is 17.5th value. Okay, the next thing we need to do, okay, so from the graph, so I'm going to do the exact same thing. 17, so this is 15, so 17.5 is somewhere here. I'm going to draw a horizontal line where it intersects the curve. I'm going to draw a vertical line, and I'm going to use that to estimate the Q1 value. From the graph, Q1 is approximately, okay, it's 150, 151. I guess it's about 151. I'm going to try to keep it to 3 significant figures. For Q3, well, that is 3/4 of 69 plus 1, which is 70 times 3 divided by 4, which is the 52.5th value. From the graph, Q3 is approximately equal to, so let's do this again, 52.5 is halfway between 50 and 55, and then I have to draw a vertical line, try to be as neat as I can, and I get an answer. Okay, this is 158, so this is probably 159 about. So the IQR then, the interquartile range, well, that's Q3 minus Q1. That was from our lesson yesterday. And so that is going to be 159 minus 151, which is 8. So, and look at what that means. That's a powerful number, right? This is the 50% of the finishers finished in the IQR, and that was an 8-minute difference. So in 8 minutes, 50% of the visitors, of the finishers came through. And we saw that, right? We saw this very steep increase where a lot of people added to my cumulative frequency. Okay, number 3. Let's continue along here. The number of competitors who finished in less than 153 minutes. Just going to get a different color here. So now we're going to go backwards this time. The number of competitors who finished in less than 153 minutes. Well, here's 152, 54, so 53 is somewhere here. So now I'm going to go backwards. I'm going to draw a vertical line from 153. If you want, you can draw, just to show you, I'm drawing arrows this way. So it looks like that number, wow, it's almost too perfect. I got it come out at 25. So from the graph, around 25 competitors finished in less than 153 minutes. So you think about it, 153 is a really fast time. So how many people were faster than 153? Well, it was a small number. It was only 25. That's not to be confused with number 4. Number 4 is asking, what percentage of competitors took more than 157 minutes? Okay, so 157 is here. So again, I'm going to do the same thing. I'm drawing a line up and then across. You can show arrows if you want. So it looks like from the graph, around, what is that, 45, say 46 competitors. Now remember, 157 is pretty good, so actually only up to the first 46 people finished before that time. So 46 competitors finished in less than 157 minutes. But that's not what the question was asking. The question was asking the percentage of competitors who took more than 157. So therefore, we just found out the number of competitors who took less than 157. So we have to find how many took more. So that would be the other, well, there were 69 in total. If 47 of the, or 46 of them finished in this time, then the ones who took more, I subtract, and I get 23 competitors finished in more than 157 minutes. So therefore I have 23 divided by 69 times 100%. That gives me 23 divided by 69. Oh wow, that's pretty nice number. 33.3%. Remember, that should be 3 sig figs. So one thing to be careful of, read the wording of the question carefully. Sometimes it's talking about less than a cutoff, sometimes it's talking about more than a cutoff. You have to use your brain a little bit to think of what's being asked for. In running, a low time is good, but if I was measuring, quality of apples that I picked off apple trees and looking at mass, well, low mass is not good. I want a high mass. I want a big apple tree. So in that case, a good result would actually be on the upper end. So just make sure you're thinking about carefully about what the question is asking. Okay, we're almost done. Oh, number 5. The time taken by a competitor who finished in the top 20%. Okay, well, now we have to work way backwards. The 20%, top 20% of 69. Well, remember, in math class, of means multiply. So what's 20% of 69 mean? Well, that's 13.8. So I want to figure out who was the 13.8th runner. Again, the top 20% are the lowest numbers, right? The first 13.8 runners. So we're going to do this one more time. I'll use orange again. Why not? We're going to go from 13.8th runner, so that's the 15th, so probably around here. This is 150, so oh, did I make a mistake here? Oh, it's 151, I guess, again. From the graph. Around 151 minutes is needed to be in the top 20%. Okay, someone's gonna ask me about significant figures and just about rounding. I mean, technically, our answers in IB should be good to 3 significant figures unless otherwise stated. So when I read off the graph a number, I should only be able to read it to an accuracy of 3 digits in this case. 3 significant figures. So that'll be my answer to that question. That's why these both tend to be pretty close together, but because we can only read so well off the graph. Hopefully that's correct what I just said. Okay, we have one more question, which is to draw a box and whisker plot for the data. Luckily, we just did a whole lesson on this, But we'll open up another page just to do this last question. So this is 4.4 page 2. So VI, I need to draw my box and whisker plot. If you remember, I need to know those five statistics to help me do this. I need the max, the min, the median, and Q1 and Q3. Now the max was the max time it took, which was 176. The min time was 146. The median, we got them before. The median was 155. The Q1 was 151, and my Q3 was 159. Okay, so now I'm going to draw the box and whisker plot. Now the way I recommend to draw it, I try to draw it to scale, so graph paper is the best, but not happening in this situation. So I'm going to draw the median first. That is 155. Now from there, I go 4 up or 4 down to get Q1 or Q3. So actually, this is very nicely symmetrical data. So I'm going to do my best to draw that box and whisker plot to be perfectly even. And this is 151 and 159. Okay, now I need to draw the whiskers. Well, the min to Q1, that's a distance of 5. This was a distance of 4. So really, isn't a very long whisker. It's about the same distance, maybe a little bit longer. And that's 146. The max is 176, which is actually 17 higher. So it actually is way over here. Something like that. I don't know. As best I can. If I had graph paper, it'd be more to scale. So then we can figure out that the IQR is equal to 8 in this case, and the range is equal to, what is that, 30. If you wanted to analyze this, you could say the middle 50% finished middle 50% of the data is symmetrical with IQR of 8. You can make an observation like that, and you could say that, you know, the data is skewed to the left. Right, in general, most of the finishers finished in the first, earlier. Okay, so that is our lesson on cumulative frequency. As you can see, it's one concept, and then we just have to use that idea, that graph, to do all sorts of things. So page 273, number 1 to 7, is your homework for tonight. Good luck with that, and we will see you next time.